Science Unit 2 is all about electricity, and we're looking at the first lesson to build our understanding of an electrical circuit and what is required for electricity to be able to move around a circuit. So, first of all, what is an electrical circuit? Follow along as I read it. An electrical circuit consists of different electrical components connected together to allow electricity or electrical energy to flow around the circuit. Any object that needs electricity to work contains at least one electrical circuit. So around your house, there are many electrical circuits. Any device basically that runs by electricity will have an electrical circuit in it. Some examples of these objects are televisions, computers, mobile phones, torches, and even game consoles. Now, for an electrical circuit to work, electricity must be able to flow uninterrupted. That's the important part, in a path around the circuit. So, for example, when you switch a torch on, the electricity flows from one end of the battery through the wires and the light bulb and back to the other end of the battery to make the light bulb shine. So, the main components of an electrical circuit are the power source. That's a good scientific word to use. We'll call it a battery or a cell at different times. And it can even be the mains electricity, such as when you plug into a power point. That is your power source. Wires. And another science term that you need to know is the word load. And basically, in terms of science, a load is any object that uses that electrical energy to do something. It could be to create heat, to cast a light, to move, any of those sorts of things. Each of those are a load. Over here, in terms of when we do science experiments, these are the types of things that we can use. Wires, and you can see the plastic over the ends, that's insulation, a light bulb, which is the load, and a power source. Alright, so we're going to explore some simple circuits. The electrical components of a simple circuit can vary according to the task you want it to achieve. Turning on a light or sounding a buzzer are examples. So this table shows the role of each component. So you've got the power source, and that's an image of it, such as a battery, and it's the energy source that provides energy to the electrical circuit. Wire allows the transfer of electrical energy to flow from one part of the circuit to another, and then a load such as the light bulb or the buzzer, and these devices or components consume electrical energy. A light bulb lights up, a buzzer produces a sound when electricity flows through them. So a battery contains stored chemical energy, and when it's connected to an electrical circuit, the chemical energy is transformed or changed into electrical energy. The electrical energy then transfers from one end of the battery around the circuit, through the wires and the load to the other end of the battery. Now that term is called electrical transfer. So electrical transfer is that change from one form of energy, such as chemical energy, into electrical energy. When the electrical energy flows through the load, for example, a light bulb, the electrical energy is transformed into light energy. So that's another transformation there. This is called electrical transformation. All right, so I want you to think about what we've been talking about and see if you can tell me the requirements for electricity to flow through a circuit. Keyword there being a circuit. See if you can jot down an idea for that one now and pause the video, come back in a minute and see what you wrote. Okay, let's see how my definition compares to yours. For electricity to flow through a circuit, each electrical component must be connected to each other. Now that's very important. Everything must be connected. If there's a break in the connection, electricity will not flow, and therefore it's not a complete circuit. So there must be no breaks or gaps in the circuit. Now you might have mentioned it needs an energy source, and you're not wrong, it does. But if we're looking at what it needs to flow, then the very important element to remember is that there are no gaps or breaks. Alright, here's a very simple little task. Complete the close. Here are the 3 words that are missing from this short sentence. See if you can work out which word goes where. So pause the video and have a go at that. Alright, let's see. A something circuit. A complete circuit is when what type of energy? Electrical energy can flow freely around a circuit. Alright, I want to have a look now at some definitions that we need to know for this unit. So I'll just go into this area. Alright, so the first thing is a circuit. Now a circuit is a pathway around which electrical energy can flow, and there are 2 types of circuits that we often refer to: a complete or a closed circuit, and the little diagram here shows in the form of a paperclip a wire connecting 2 ends. It's a simple little homemade circuit switch, I suppose you could say. Here it is open and therefore electricity won't flow because it's an incomplete circuit. So switches must be closed for a circuit to be complete, and if the switch is open or an electrical component such as a light bulb is broken and electrical energy cannot flow around the circuit. Alright, jump over to this one. Electricity, it's another term. Basically, it provides the electrical energy for electrical devices. And the picture there shows a mains power point where we access most of our electricity. Energy, all right, what does that mean? Well, energy relates to the ability to make things happen or to cause change. Energy is required to make machines work or bulbs glow. We use energy just to move. Okay, so energy comes in a number of different forms, and we'll build our understanding of energy as the unit progresses. Energy transfer is another term that we need to understand at the moment. Energy transfer is the movement of one type of energy within or between mediums. So the diagram shows a person holding a baseball bat. Now the movement of energy from a bat is transferred to the movement energy of a ball in baseball. So when the bat strikes the ball, movement energy is transferred from one to the other. And energy transformation. Now that's changing from one form of energy to another. Okay, so it's not just movement energy transferring from one thing to another, which was that energy transfer. Transformation is a little bit different. It's actually different types of energy and changing one into another. Solar energy is a common form of energy transformation, where the energy from the sun through a solar powered cell, such as this one in the diagram, found in many homes, through a particular process, and again we'll learn more about what that process involves, it can actually change it into electrical energy, so from solar energy into electrical energy, and it's the electrical energy that we can use to say do something like power a vacuum. Okay, let's continue here. I've been through that part, so I'll just jump onto this one. All right, here's a bit of a close exercise. There are 9 missing lines through here, and there are 9 things through this. I want you to see if you can pause the video and work out what these are. If you're really on the ball, you might like to write it down and have a go that way. But otherwise, you can just pause the video, look at the screen, and see if you can work out where things go. Pause the video now for me and have a go at this exercise. How did you go? Bit harder than it looks? Maybe, maybe not. I think some of you would have done very well. Let's have a look. An electrical circuit consists of different electrical components connected together to allow something around a circuit, to allow electricity to flow around a circuit. Any object that needs electricity to work contains at least one electrical circuit. Some objects that contain electrical circuits are, all right, so we've got mobile phones, game consoles, obviously we're listing things here, so televisions and computers are two more things that can contain electrical circuits. For an electrical circuit to flow, energy must be able to flow uninterrupted in a path around the circuit. For example, when you switch on a torch, the electricity flows from one end of the battery through the wires in the bulb and back to the other end of the battery to make the light bulb shine. Okay, so the main components are a power source, and examples of a power source are a battery or a cell, wires, and a load, and that's the object that uses the electricity, and two loads there are a light bulb and a buzzer. How did you go? All right, so here's another basic circuit that contains a switch, a battery, and a lamp. Do you remember the other word that starts with L for whatever uses the power source? It's a load. All right, so now this last little diagram here talks about energy flow. So electricity is a flow of electrons. So electrons are the negative element within an electrical flow, and they flow from negative through to positive. And in this diagram here, it flows through the load or the light lamp and back to that end of the battery. And then over here in this diagram, we've got the negative part of the battery, the positive part of the battery, and the electricity will flow. So the electron charge moves from the negative, which has a surplus of electrons, through to the positive end, which has a deficiency of electrons. Okay, guys, well, that's it for today. I hope you learned a little bit about electrical circuits, and we'll continue with our developing our understanding in the next lesson. All right, thanks, guys.